My approach today, this evening, is going to be a little different from what you have seen or listened before through the conference. I'm going to talk to you more about the next step on our emerging discipline of medical geology and how we are going to be, what we need to do to really enhance and strengthen the pathway to provide a more integrated approach of the sciences, environmental health sciences, and also public health and the other type of allied sciences. What we can do to make it more integrated into medical geology. And I'm going to give you some examples. I'm not going to talk about the research today. I'm going to give you some examples, some ideas. And I would like to spike your interest on this particular topic. Many of you that have listened to my talks at different conferences are going to see that some of this material has been probably discussed in different forums. And the objective, the main objective is to be able to highlight throughout these presentations the contributions that geoscientists and public health has made to the development and implementation and growth of medical geology globally. So my path is going to be a little different from what you have been listening during the last few days. Let me just, Elena, can I just share my screen?
Yes, Dr. Centeno, you should be able to share.
Yeah, let me see. How can I do this? I'll share screen. Okay. This is, how can I do this? I'm sorry, it's not showing up. How can?
Okay, you're now sharing the desktop.
You're sharing screen. I'm sharing my screen, but it's not coming up. So what do I do?
Do you see on the bottom bar you're presenting up?
Yes, I new share. Let's see if I can just allow share screen. Okay. Oh my goodness. Now is a problem. Let me see if I can just give you this.
Or when you press on share, what do you see?
I see the sign, the logo of the SCGH. See, I can share this screen.
Oh, okay. Then now stop the sharing, press on stop share, and then press again sharing on the bottom.
Okay. And then
in the
share
next
screen, right?
window, you should select the application you're trying to share.
It's not coming through, Carlos. I'm really sorry. Let me see if I can do this again. Share the screen. Oh, man. Okay. Can you see that now or not?
Okay, now we see the desktop. May you try to put it in full screen?
Yep. It's going to take a few seconds. Now, can you see the screen, the full screen?
Yes, it's working now. Thank you.
Perfect. Okay, that's good. Okay, So the topic that I selected or I choose for this presentation is the basically it's kind of a long title, but we are going to be talking more about how we can what has been done so far in our discipline of medical geology to promote the integration of environmental sciences, public health, and earth sciences as a way to better understand the potential health effects of earth materials. And this is a combined effort of many, many colleagues throughout the globe that has been working with us for the last 20, 25, 30 years in looking at this particular area of work. I'm delighted that during this conference you have seen plenary speakers that have already talked to you about projects that actually contribute to this particular area or to this particular topic that I have selected of integrating disciplines to our sciences areas to our discipline of medical geology. So what I'm going to do is to give you a very brief introduction on this. And the introduction that I have going to give you is a little bit more about the medical geology. I think that by now many of you know the definition of medical geology, what we are trying to address, what are our goals, objectives, and aims, what is the mission and vision of our association, the International Medical Geology Association. But I would like to also give you a little bit more on that definition. I would like to as we move along this presentation. Another topic that we will address very quickly will be exploring what I call gaps in knowledge of the evolving areas of medical geology and what geoscientists have been able to do to and public health scientists to bridge this gap. This comes from previous research that we have done, and it comes from a previous type of programs that have been developed on medical geology. And then I would like to conclude, give you a few concluding remarks or concluding comments on this particular topic. I'm going to talk a little bit about the future of medical geology, and then I'm going to provide you with some thoughts that to challenge you to think about how we can broaden our horizons as we continue developing medical geology worldwide. And what are the areas that are coming up right now that will enhance the impact of medical geology worldwide? So just to stand a little bit about the definition of medical geology, by now you know that medical geology is an emerging or re-emerging, actually, discipline that the objective or the goal is to study the relationship between geological materials and geologic processes, and the impact of these materials and processes will have or may have in the health problems, not only in humans but also in animals and the ecological environment as well. The scope and range of medical geology is to identify, characterize, and to provide information about the sources from and the pathways, as well as the processes leading to health issues from geologic materials, natural geologic materials, and also to develop technologies or tools that allow us to predict the movement and changes of chemical, infectious, or even disease-causing agents. In reality, the basic thought that I want you to take from this definition is that the power of medical geology lies in the ability of us capturing principles and concepts from several allied disciplines and to unify them in a single place, thus contributing to a more holistic approach to disease diagnosis and therapy. This definition is basically telling you that medical geology is as an emerging or re-emerging discipline, is a multidisciplinary discipline that brings together geology, public health, and environmental sciences. But in addition to that, we have to consider the many areas that are involved in this type of integration or in this type of involvement. Areas such as geography, epidemiology, toxicology, pathology, chemistry, biology, climatology. Today is so important, studying climate change, engineering, and even the sciences that we sometimes don't consider that are have a area to contribute, but sciences such as social sciences, economics, and politics, regional areas that provide us with a more integration pathway for these sciences into medical geology. So, in terms of what has been done in the past, that, in my opinion, allow us to continue bridging the gap in knowledge that we have in areas of interest of research to our students and to our researchers on medical geology. I want to bring to you, basically at this point, a little bit of terminology that is allowing us to bridge these gaps on research and impact of medical geology and integration of medical geology. But also, I would like you to consider this. I would like you to consider that the integration of environmental sciences, public health, and earth sciences, it involves a combination of providing the very specific characterization of earth materials by looking at the geochemistry, the mineralogy, and using perhaps laboratory methods that we have developed today that could be in vitro extraction test of simulated body fluids, or even in vivo test of that can be done to understand the interaction of geologic materials, natural geologic materials, and with the human body. And in addition to that, using that information to integrate it into population studies, looking at the application of epidemiological data, toxicological data, and then also methods that we use in public health to monitor the health of populations across the globe, like biomonitoring. And all that today, the goal is, as we continue working on the integration of these areas into medical geology, is to create tools that allow us to understand more about the risk to human health from geologic materials. So these areas, for example, creating health risk maps has been done in the past, and today continues to be a unique tool towards the integration of medical geology to these areas. Now, I want to take the example of one particular area that has been kind of a trademark of work both in geosciences and also in public health. And when I say kind of a trademark, these are materials that are both in the natural environment or in the anthropogenic, man-made environment. And I want to talk to you about principles of environment that has been developed by geoscientists in environmental geochemistry as applied to research on medical geology, particularly with focus on metal contaminants and metalloids. And this area has been unique in terms of developing terminology that allows to understand the science that we apply and understand the science that needs to be developed towards this particular area of research. So, for example, I want to bring to your attention this area that geoscientists have particularly contributed to the study of medical geology, which is the area of geotoxicology. This is an area that studies of the geological, mineralogical, geochemical, biosolubility, and bioreactivity characteristics of earth materials that influence toxicity. So this is a unique approach that has been developed by geoscientists as a way to integrate the geochemical information into public health studies. This area has been coined basically by our colleagues from the U.S. Geological Survey, Dr. Jeff Plumley and his group, looking at how geotoxicology studies can better explain or contribute to public health studies. But in addition to that, the area of geotoxicology allows to better understand and develop studies on areas that cross boundaries between public health and geosciences. And that's when we looked at geoavailability or bioavailability or bioaccessibility. The area of geoavailability is really a unique approach to the study of geologic materials and natural events. Because in the particular case that I'm trying to describe to you this morning, which has to do with metals or metalloids, this area looks specifically at that portion of metals or metal-bearing compounds, total content in an earth material that can be released or liberated to the superficial or near surface environment, in a sense to the biosphere, through processes such as mechanical processes, chemical processes, or even biological processes. The definition, this is the basic definition of geoavailability. Basically, what it's telling us is that in order for a metal or a metalloid in an earth material to be bioaccessible and eventually bioavailable, it must first be geoavailable. I'm sorry. So this is an important contribution of geosciences to public health and medical geology. Now, the continuum is basically that interaction between what we call in toxicology and public health the bioaccessible fraction and the bioavailable fraction, in which the bioaccessible fraction is that which is soluble in various body fluids, such as gastrointestinal respiratory fluids, perspiration, even blood. And the bioavailable fraction is that actually reaches an organ or that is retained in the body and transported within the body to a site of toxicological action. So these are the terms that we use in toxicology and public health to describe toxicity of materials. But the geoavailability, the geotoxicology, geoavailability studies developed by geoscientists have provided the integration of those studies into the toxicological public health work, understanding bioaccessibility and bioavailability of geologic materials. The example that I can give you very, very quickly is this is a slide put together by my colleague Jeff Plumley from the U.S. Geological Survey, and he shared this slide with me. But this shows beautifully the fact that not all forms of lead are readily geoavailable and hence and therefore bioaccessible. And this plot compares soil lead to blood lead levels in children living in mining areas, smelter areas, and urban sites. And you can see that there are sites here, urban sites, that there is a correlation between the geoavailability in those sites, in the urban sites, and the blood levels of lead, in the blood of children. There are mining sites that even the concentrations of lead are higher, but there might not be they might not be geoavailable and hence bioaccessible. So these are studies that shows the integration of geosciences and public health. Additionally, if you look at metalloids like arsenic, the public health community has been really working hard in understanding the exposure to geogenic arsenic, particularly from contaminated drinking water. And they have used the geoscience principles and tools to identify arsenic, to provide information about the levels of arsenic in those sources. But the public health area has been unique also in terms of looking at markers, biomarkers of exposure, looking at biomarkers of toxicity, looking at biomarkers that we can use to actually describe the impact of arsenic. For example, looking at the speciation of arsenic in body fluids, like in urine, to determine the likelihood of an individual to develop toxicity from a specific geologic source to arsenic. So these are, again, contributions of the public health area to and the geoscience area to topics that are of global concern in public health. There are emerging topics that medical geologists are looking into, and in this conference, you have listened to some of these topics, and there are emerging topics dealing with atmospheric dust and soils and other earth materials, where interdisciplinary medical geology research methods have been developed to understand exposure to that. Understanding the mineralogy and geochemical characteristic of volcanic ash has been a medical geology program developed worldwide, and also understanding the release of and transport of atmospheric dust globally. Now, all this information today is being used to create health risk maps. This is a slide that is a little bit old in terms of the topic, because here we are just showing you how we have used the information, for example, in the topic of asbestos, to the geochemistry of that, to create health risk maps through the US. Similarly to this topic, colleagues in other countries, for example, in Slovenia, in many other countries, have used this same principle of looking at the composition of natural contaminants in soils and looking at the registries of morbidity and mortality in their regions and countries to establish health risk maps that for population at risk to many of these materials. So some of the concluding remarks that I would like to bring to you. First, I just want to tell you that to our students that the future of medical geology is very bright, is powerful, and brings together communities all across the globe. There are areas that medical geology scientists and public health scientists are working continuously. Like when you look at the impact of global climate change, the continued issue of dealing with natural disasters, new areas such as urban medical geology, veterinary geology, of course, atmospheric dust, and particularly the interest here is the interaction with microbes and pathogens and minerals. And even today, we are interested also to know about persistent environmental pollutants, such as microplastics, which might not be an area of medical geology because it's more anthropogenic, but it's an area of environmental health sciences that can actually contribute to the integration to studies of medical geology. Occupational health, as well as what are the mechanisms of interaction of many of these diseases and natural components with the human body. Now, as a final thought, I want to spike your interest to our dear students. I want you to think about where we can go and where we are going with our discipline of medical geology. How we can broaden our horizons. And there are three particular topics, I think, in my personal opinion, that are the medical geology will continue to inspire researchers, students, and organizations across the globe. From mentoring, which in that area I mean looking at the establishment of research centers of excellence that provides us with the opportunities to create creativity and problem solving to protect populations at large. From inspiring, the interaction, getting our students working on topics that are of provide subject matter experts for medical geology, and that interaction between mentors, researchers, and students is a passion of inspiring globally for medical geology. And another part that I think is important for us to consider for the future is, of course, is that involvement of our students in medical geology, establishing the connections and applications of medical geology to society, demonstrating the relevance of medical geology to society. And very important is to foster interactions with national and international organizations. Let me just give you two examples, very quick examples. When you look at mentoring, I would like you to look into what is being done in some areas around the globe. In this particular topic, right now we are very delighted and it's a great honor for us to bring this information to you, in which there is a center that there are efforts to establish centers of excellence on medical geology. And the first one that has been established is a center that is it has received the sponsorship and from the Nasarawa State University in Kefi in Nigeria. It was established in 2020, and the objective of this center is to serve as a training facility for students pursuing their master and doctorate degree in medical geology, and to promote the field of medical geology throughout Africa and the globe. This is a unique opportunity for if our students are looking into how to pursue a professional degree on medical geology. This will be one of those available facility centers in around the globe that you can pursue that. The professional graduate programs that we are actually pursuing right now is a postgraduate diploma in medical geology, and also both a Master of Science and a Doctor of Philosophy in medical geology are the three programs currently available at this center. So I encourage you to visit the website of this center and look at if you are interested in pursuing some of the projects and degrees that are offered by the center. In terms of interacting with organizations, there are many opportunities for medical geologists to do today. This is I'm pretty sure that you have seen this list of the United Nations Sustainable Development Goals. This is a list of 17 goals, and the objective of this goal is to reduce the number of deaths and illnesses from hazardous chemicals in air, water, and soil pollution and contamination. And there are about 7 of these goals that are of relevance to medical geology, from climate change, from the issues dealing with the good health and well-being. So that if you looked at each one of these goals, medical geologists can contribute to with research, integrated research, and tools to understand more about how we can reach this particular objective through interactions and collaborations with the UN and other organizations looking at these goals. So with that, I would like to thank you all for the opportunity to having me today to talk to you about this topic of integrating medical geology to and many of our disciplines and allied sciences disciplines. I would like to encourage you to look at some of the information that I presented today during this short presentation. And if you have any questions, I will be delighted to talk to you. Just email me or just send you questions or a comment or request to our dear IMGA secretary Elena, and Elena will ensure that we address your concerns and your comments and requests. So thank you so much, and I wish you a great success on for the rest of the conference.
Thank you so much, Dr. Centeno, for your presentation. Thank you for sharing to us the relevance of the medical geology application to the society, the emerging topics converging in medical geology as an interdisciplinary discipline, very relevant and necessary to address several issues like the health impact of the global climate changes, the relief, how to know and how to study the release of contaminants from the anthropogenic activity, who impact in our health and in the environmental health. So thank you so much for your presentation. If somebody has any question for Dr. Centeno, please let me check here in the chat. And I have a question for you, Dr. Centeno, from Adriane Aguiragui. Dr. Aguiragui says that in terms of collaboration, I will also suggest to continue our joint effort for outbreak between IMGA and CH. This conference a bright example of fruitful collaboration between joint forces. Yes, of course.
Yeah.
Thank you.
Yeah, I agree with that, Elena. It's a unique opportunity to really foster these interactions with the Society of Environmental Health, as well as other societies that they have a mission of protecting public health and the environment.